We are now on to residual plots. This is the part of our lesson where things get a little more complicated. Residual plots are a very useful tool in determining whether or not a linear model is appropriate for our data. At the beginning of this unit, we talked about how scatter plots can have different forms. We can have a linear form, a nonlinear form, curved form with two clusters. Linear scatter plots are not the only scatter plots that exist. They are just the scatter plots that we have been focusing on for the past couple of lessons. We need a way to determine whether or not a linear model is appropriate for the scatter plot we're seeing. You'll see an example of where a linear model looks appropriate, and then we we find the residual plot, and it turns out a linear model is not appropriate. Our fill in the blanks here are residual plots help us assess how well our linear model captures the relationship between variables. How well our linear model captures the relationship. How well it captures the relationship. A residual plot is a scatter plot of the residuals against the explanatory variable. That may not make a whole lot of sense at this point. Hopefully, by the time we get to the bottom of this paper, it makes a lot more sense. Residual plots help us assess how well our linear model captures the relationship. A residual plot is a scatter plot of the residuals against the explanatory variable. As with most things in this class, we're going to investigate what this means by doing an example. Our example is 9th grade students at Webb schools go on a backpacking trip each fall. Students are divided into hiking groups of size 8 by selecting names from a hat. Before leaving, students and their backpacks are weighed. The scatter plot for this data is given. Construct a residual plot. We are deciding if a linear model, so I could just roughly sketch a line. We're deciding if a linear model is appropriate for this body and backpack weight data. To do this, we're going to rely pretty heavily on our calculator. Step number 1 is to enter body weight into list 1 and backpack weight into list 2. You do not have to use those lists. I am going to use those lists because they're going to make the process that we're about to follow a little bit easier. Remember, when you go to enter your data, that if you need to clear out your list, you want to go up to the top and highlight the list name, hit clear, enter. So highlight the name, hit clear, enter. While you're doing that, you're going to need, by the time we're done with this example, we're going to be filling in list 1, list 2, list 3, and list 4. So I just went through and cleared all of those out so that they're ready when I need them as we move through this problem. Pause the video and enter in your data, then come back when you're ready to start with me with your data entered. Okay. It's always a good idea down here to verify that your lists are ending at the same spot. That usually gives me a good indication if I entered things in right. And then I usually check at least the first and the last value to make sure that they match. So the first should be 120 and 26, and the last should be 116 and 28. What we need to do in order to find our residuals, because this is a residual plot, we need to know the predicted y for all of these x values. We have x and y, but to calculate the residuals needed for a residual plot, I don't know why I have my mask on. I had somebody in here a second ago, and they're gone. They've been gone forever. We have our x, we have our y. In order to calculate a residual, we need y hat for every x value. The first step in order to calculate y hat is to find the regression line. First step, find the regression line. So we're going to hit Stat, arrow over to Calc, choose option 8. I need to change mine to list 1, blue button, 1, enter, blue button 2, enter. If we entered in our data correctly, our regression line is 16.26 and 0.09. I'm letting the value of our slope dictate how much I want to round to. So 2 decimal places seems to be about appropriate. You could go 3 if you wanted to. Let's copy this regression line right here. Our predicted y is equal to 16.26 plus 0.09x. To get all of the y hats for these values, we could plug them in. So we could say 16.26 plus 0.09 times 120. Oops, I hit tan. Family, why does this happen? It's because of these new claws. So 2706. Then we could do it for the next one. So I'm just going to come up here and still it. Change this to 87, 3309. That's one way. We can go through, calculate predicted values. If your body weight's 120, we predict your backpack weighs 27. Body weight's 187, we predict your backpack weight's 3309. A faster way is to use the lists in your calculator. So list 3 is now going to become a list of your predicted values, and here's how you do that. We go to Stat 1, go into the name of the list, so we're on list 3, and type in the regression formula. So you're highlighted on list 3, you type 16.26 plus 0.09 times, and all of our x values are in list 1. So we're going to hit blue button 1. Enter, and now your calculator has found all of your predicted values. Right here, let's verify our values. Our first one that I got was 2706. That's the same. Second one, 3309. That's the same. So these are now our predicted values. I'll read them off for us. All you need to do is copy them in. Next one, the predicted y for 109 is 2607. Then 3309. Just kidding. Teacher, you're letting us down. 2607, 2553. 2805, 31.11, 30.48, 26.7. Now we have X, Y, predicted Y, and our last step is residuals. The formula for residuals is Y subtract Y hat. I can go through and calculate the residuals using my calculator one at a time. This first one would be 26, not in there, sorry about that. 26 subtract 2706, that gives us a residual of negative 106. 30 subtract 3309 gives us a residual of negative 309. You could do that for every value, or we could plug it into our list just like we did on the last one. So we hit stat 1, and now in list 4, I'm going to have it calculate my residuals. So I have it highlighted on list 4. I'm going to hit blue button. My actual Y values are in list 2, so blue button 2. Subtract. My predicted values are in list 3, blue button 3. Enter. And my first two values in this table are the same two values here if we wanted to calculate it by hand. Once again, I'll read them off. I'll try not to mess up. Negative 0.07, negative 1.53, 0.95, 3.89, 0.52, 1.3. Now we have everything that we need to calculate our residual plot. When we make our residual plot, what we are using as our X is this same X. You keep the same X value. What we put on the Y is our residual for that X value. I'm going to draw the axes. And because our X is the same, I'm just going to use the exact scale that they have. It looks like they're going by tens, and they start at 100. I guess I could have spaced mine out more. I'm going to do mine slightly more spaced out. That was a lot better. Remember, we always want to not only scale but label our axes. So I'm copying exactly what I have here, because our X values stay the same. What goes on this side is our residuals. And usually right in the center of our our Y axis is a residual of 0. Remember, a residual of 0 is when your actual, well, I guess I shouldn't say remember because we haven't talked about this. You get a residual of 0 when your actual value and your predicted value are the same. The only way you get a residual of 0 if your actual value and your predicted value are equal to each other. Okay, let's look at the range of values on our residuals to know how we want to scale. So we go as low as it looks like -3 and as big as almost 4. If this is 0, then let's make this 4 and let's make the bottom -4. Now we cut that in half. That would be 2, -2. Cut those in half. That gives us the rest of our ticks. Remember, this y-axis is our residuals. So I'm kind of running over into the next thing because I haven't left enough room. For our first point, what we're plotting is that a person that weighed 120 pounds had a residual of -1.06. So we're just going to do the best that we can to graph these. Remember, they don't have to be perfect. You just estimate as best you can. A person that weighed 187 pounds had a residual of -3.9. So 187, very high up. So these 2 points that we just plotted, what this means is, for a person who weighed 120 pounds, the actual weight was less than the predicted weight. It was less than by 1.06 pounds. And this one means for a person that weighed 187 pounds, the actual weight of their backpack was less than the predicted weight. So I put this on the wrong end. Teacher, come on now. So this guy should be all the way down here. Sorry about that. So these are both negative residuals, and notice they are under this line where the residual is 0. Okay, next up, 109 and close to 0, -0.07. 103 and -153. 131 and 0.95. 165 and 389, so that's really high. 158 and 0.52. 116 and 1.3. All right, so the biggest takeaways at this point are that we need to have a very strong understanding that your x-axis is the same in your scatter plot and your residual plot. The other thing worth noting is your y-axis is your actual residual that matches the x value. The last thing is that these two graphs are related. You only make a residual plot when you have a data set that you are questioning or verifying that a linear model is appropriate. We're going to add on to this now. In our previous example, I colored in the top of the prediction line and the bottom of the prediction line with different colors. I'm going to do something similar here. So I'm going to highlight. I'm not sure that this is the actual prediction line, and that's okay. I'm just drawing that in for my reference. Once again, the points that are above have a positive residual. Is that true? Yes. And the points that are below have a negative residual. How this translates to your residual plot is that your prediction line is now 0. These two represent the same thing. These are all of your y hats. Remember, if you have a residual of 0, your y hats and your y equals. So we don't have very many points on our green line because we don't have, very rarely is our prediction the same as our actual value. So this line translates to this line, which now means that I have 1, 2, 3, 4 points above my green line here, which means I will have 1, 2, 3, 4 points above my regression line. So I actually did a pretty good job of drawing in this regression line because they should match. If you have 4 points above the regression line, then you will have 4 points above your 0 line on the residual plot. I have 1, 2, 3, 4 that are very close or below. So I've got, my line isn't so awesome because I have these two that look for a little further away. Like, according to my line, I should have 3 that are very close to the green line, and I only have 1 that's very close to the green line. So this one right here, oh, I see. Do you guys know what I have wrong here? So this one really is over the line, and this one should really be under the line. Not on this. Don't change yours. I probably said that backward. I will point this out further down here, where we actually have the regression line and the actual residual plot next to each other. But essentially what I want you to take away from this is that if you have a regression line here, it shows up as your 0 here, and then all of these points that are above the regression line are the same points that are above your 0 line. So they should be the same number. The same number of points above here should be above here. And it goes the same for the bottom. So mine is not 100% accurate because I just rough-handedly, I don't think that's a description, I just estimated where the line would be. Okay, so now we have our scatter plot and our residual plot, and it's been like 4 years since we even started talking about residual plots. So we need to remind ourselves what the purpose of residual plots are. The purpose is that residual plots help us verify or decide or determine if a linear model is appropriate for our data. The question is, given this scatter plot, should we describe this scatter plot with a straight line? And the answer is, look at your residual plot. And here's how you decide. You want to consider the residual plot to be a visual of the relationship that's left over, after the linear model is applied. So what we're trying to say is this. We have a relationship between these two variables. How much of that relationship is captured by a linear model? So how much of that relationship is captured by a linear model? The leftover is the relationship that the regression line does not explain. So consider the residual plot to be a relationship or be a visual of the relationship that's left over after you apply the linear model. It's the relationship that is not explained by the linear model. If there is random scatter, then there's no leftover relationship. If a linear model is appropriate, then you will see no leftover relationship. What that means is your linear model did such a good job of capturing the relationship that when you look at the residuals, there's no relationship left over to be explained. So I'm going to say that one more time. If your linear model captures the relationship, that means that your residual plot will show a random scatter of points. And the reason that it'll be random is because there's no leftover relationship. The relationship between the two variables was captured by the linear model or is explained by the linear model. When an obvious pattern, which we've discussed previously as form, when an obvious pattern exists in a residual plot, a linear model is not appropriate. What that means is there's some relationship in the data that your linear model did not capture, so you don't want to use a linear model, you need to use something else. I'm going to say that one more time. If you look at your residual plot and you can see a pattern, that means that your linear model did not capture the relationship. The relationship is still there because you can see it in the residual plot. So let's look at two examples of where a linear model is appropriate and where it's not. So these are exact, and what I mean by that is what I was trying to explain above, and we can actually count these, is look at how many points are on your prediction line. 1, 2, 3, 4. Notice that on the 0 line of your residual plot, you have 1, 2, 3, 4 that are very close to that line. Here you have 1, 2, 3, 4, 5 points that are above the line. Here you have 1, 2, 3, 4, 5 that are above the line. So this one we're considering to be this one that's very close. No, this one that's very close. So let's count these ones. Do they match up? 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. So what I want you to be noticing is that your scatter plot and your residual plot are going to have some similarities. The prediction line is mirrored here on your residual plot. All points that are above your regression line are above the 0 line, and all points that are below the regression line are below the 0 line. This is random scatter. This means a linear model is appropriate. Linear model is appropriate. This one, if you look at just the scatter plot, it looks like a linear model could describe this relationship. But when we go to investigate the residual plot, there is an obvious curve left over in the residual plot. This tells you that a linear model is not appropriate because the relationship was not captured by the linear model. This is what's left over after you apply the linear model, and you can see there's still a relationship there. If there's still a relationship, that means your model didn't do a good job. So here, we applied our model, no leftover relationship. So linear regression is appropriate. Here, we apply our model, and we still have a relationship that we haven't explained. Well, that makes me go back and look at this a little closer, and if you look, you can notice that we have this kind of a situation happening in this scatter plot. So perhaps it's not a straight line model that I need to use, it's a model that matches whatever this wave is. Looks kind of like a sine wave or a cosine wave. Okay, so let's see if we got the biggest takeaways so far. Number 1, to graph a residual plot takes 10 years. It's not enjoyable. The biggest takeaway from this whole process is a true understanding of what a residual plot is showing you. For all of your x values, for all of the values you use to predict, you plot the residual that matches them. If you have the appropriate model, so if a linear model is appropriate, no relationship will exist in your scatter plot, or I should say in your residual plot. So linear model is appropriate because there's no relationship left over. Linear model is not appropriate because curved relationship left over. So linear model not appropriate. When deciding if a linear model is appropriate, the residual plot is the most important deciding factor. You usually look at residual plot and R-squared. So when deciding, you look at R-squared and the residual plot, but the residual plot is the most important one. Let's flip to the next page. Consider each residual plot and determine if a linear model is appropriate. I'm just not saying anything to give you an opportunity to look. This first one is a yes. This second one is a no. And the third one is a definite no. We've already talked about a curved relationship. This guy is like a funnel or a megaphone. You would consider this to be an obvious pattern. What you're looking for then is like a megaphone shape or a curved shape. When you're deciding, you're looking for a megaphone shape or a curved shape. Let's flip back. We're almost done. If you're hanging in there, I appreciate that. Let's revisit this data. Would a linear model be appropriate? The answer is no. It's not as easy to see, but this guy has a megaphone situation going on. So a linear model is not appropriate for this particular data set. It's harder to see than the other one, but this situation here makes it so that we don't have random scatter. We have this megaphone situation. Lots of the time what's happening in your megaphone is you're having like a relationship that looks like this. Like as your x's get bigger, your residuals increase, decrease, increase, decrease, so on. So even though we don't have a lot of points and it's harder to see, that truly is a megaphone. We've talked about a lot, and I need to add on one more thing to this before we finish up. I've mentioned how the scatter plot matches the residual plot, and if the points are above the regression line here, then they're above the zero line here. What these points are is points or predictions that have underestimated the actual value. So if it's in this section, you have underestimated the actual value. And if it is down here, you have overestimated your value. Because remember, residuals are y minus y hat. Residuals are y minus y hat. If you're up here, that means, I think I might be saying that backward. Pause. Let me verify what I'm saying. Okay, verified that what I'm saying is correct. So what I'm about to say is accurate. I'm even going to write in marker. Points that are up here have been underestimated, meaning your predicted value is less than the actual value. You underestimated what the actual value is. So these are all underestimates. These in the bottom are all overestimates, because your predicted value is bigger than the actual. You've overestimated what the actual value is. You have one problem coming up that needs you to recognize that points above the zero line are underestimates and points below the zero line are overestimates. So it's almost like the opposite. If it's positive, it's an underestimate. If it's negative, it's an overestimate. Those seem like opposites in my mind. Okay, let's finish up. and it's just the interpretation. All we have left is answering, is a linear model appropriate? Here is our Ford F-150 data. This is our scatter plot. This is our residual plot. And the question is the linear model appropriate? We look at our residual. We determine if there's a pattern. I see no pattern. No pattern means our linear model captured the relationship between the two variables, and what's left over is random. There is no relationship left over. So our model did a good job of describing the relationship. So we can use this phrase to memorize to answer that. The residual plot shows no leftover pattern. Oh, I think I'm lying. Oh, family. Why do I write in marker? Okay, here's one option. I'm starting to make mistakes because I'm feeling very bad that this video is 41 minutes long when the whole purpose of changing the format of your notes was to make the parts shorter. The bad news is this part of your lesson is very long. The good news is that this is all you're doing today besides the 3 questions in the quiz. That's it. So last video and this video, no can you do. So I apologize. I'm trying to keep them short. Okay, one option to answer is the residual plot shows a random scatter of points, so a linear model is appropriate for this data. So your first option is to say what you see. Residual plot has a random scatter, linear model is appropriate. Perhaps the better way to say it, because it shows that you have a true understanding of scatter plots, a better way to say it is the following. That shouldn't say oh yeah, it should. A linear model is appropriate for this data because there is no left over pattern in the residual plot. And this one is slightly better because you are recognizing or acknowledging that you understand that what you're looking for is how well the relationship was captured. And if a pattern is left over, you know the model didn't do a good enough job. So this is, you can use either one, and in your can you do that you will get on your next class day has one where I use both. I say there is no leftover pattern, so linear model is appropriate, a random scatter is shown. Okay, that's it. I want to pop over to the Canvas quiz really quick. This Canvas quiz is a really good example of why these questions at the end of your lesson are important to the lesson, because these last 2 questions that you see are going to challenge your thinking and make you think critically about the residual plot. So it is important that you try these problems so you know what your understanding is, because if you get them wrong, then you're missing something. That being said, it is really important that when I see you in class next time, or if you're a virtual learner, that whatever you don't understand, you ask me before we move on. You ask me before you move on. You ask me before we move on. So we're done. 45 minutes. I'm feeling so bad that this is 45 minutes. I'm so sorry. But all you have left to do are these 3 questions, and then we will finish up this lesson and get our can you do in our next class period. Okay, love you guys. I'm so sorry.